Black holes are the most powerful entities in the universe, so powerful they can tear entire stars apart into atomic-sized fragments. That alone sounds terrifying enough. But they possess an even more formidable, profound characteristic. They may devour the universe itself. Opening music. Let's briefly discuss black holes. When immense amounts of matter are compressed into an extremely small space, a black hole emerges. The gravitational pull at its core is nearly infinite, tearing anything that comes too close into fundamental particles. Not even light can escape. So to us, they appear as dark spheres. If you were to fall into one, nothing terrible would happen until you crossed its outer boundary. The event horizon. Imagine swimming in a river with a massive waterfall at the end. As you float along, even if the waterfall isn't yet visible, the current gradually accelerates. You could still swim back to safety, until, without realizing it, you cross an irreversible boundary. At that point, no matter how hard you swim, the current will inevitably drag you toward death. Anything that gets too close cannot escape the black hole's waterfall. This boundary separates the universe from the black hole. Unless we intend to turn back, we simply cannot reach the black hole. So in truth, we cannot know what truly happens inside a black hole. However, regarding what occurs at the black hole's edge, we do have some ideas. A black hole releases its mass in the form of radiation, much like a hot pot on a stove, dissipating heat by evaporating water. This is known as Hawking radiation. Black holes continuously lose minute fractions of their mass, and this process is incredibly slow. For a black hole with the mass of the Sun, it would take roughly 10 circumflex 58 years to dissipate just 0.00001% of its mass. This process continues uninterrupted, and the rate will gradually accelerate. In the very distant future, long after the last star in the universe has died, black holes will shrink increasingly smaller until they evaporate and vanish, leaving only a trace of radiation energy. However, this poses a problem. During the black hole's disappearance, it may erase some fundamental aspects of the universe. Information, also called data, the second. What is information? Information is an intangible existence, and it is commonly understood as the characteristics of particle arrangement. What does this mean? Imagine a cluster of carbon atoms. Arrange them one way, and you get coal. Arrange them another way, and you get diamonds. The essence of these atoms remains the same. What changes is the information. If we complicate this further and introduce more types of atoms, we might get a banana. Alter the atomic arrangement, and we get a squirrel. The fundamental building blocks of everything in this universe are identical, be it a bird, a rock, or a cup of coffee. Without information, everything in the universe would be indistinguishable. And according to quantum mechanics, information cannot be destroyed. It may change form, but it never disappears. For example, if you burn a piece of paper, you get ash. Essentially, that ash won't turn back into paper. However, if you could meticulously collect every carbon atom from that ash and precisely measure the properties of the smoke and heat emitted from the fire, theoretically, you could reconstruct the paper. The information of that paper has always existed in the universe. It hasn't vanished. It just becomes very difficult to read. At the point of the Big Bang, black holes become the reason we can no longer trace back further. Information tells us how things began to differ and what their predecessors were. Black holes do the opposite. They make different things become the same. They destroy information. This creates the information paradox, a serious problem. Information paradox. All our current physical laws are built on one foundation. Information does not disappear, exists, does not exist. Without information, everything becomes relative to understand reality. We need absolute definitions. How do we resolve this contradiction paradox? Several possibilities exist. One, information is gone, and irretrievably gone. This means we must reject all physical laws, discard a host of theories that have worked well thus far, and start anew. What would new physical laws look like? What would this mean for us? No one knows. That sounds a bit terrifying, yet strangely exciting. 2, the information is hidden. Perhaps a fragment of the black hole split off, forming a baby universe. The information would be transferred to this new and strange place, but we wouldn't be able to observe it or communicate with it. Strictly speaking, the information hasn't disappeared. It is like having a broken hard drive you can never access. and it contains photos of you and your family. It sounds great that it hasn't been deleted, but it is completely useless. It is also possible that black holes don't vanish entirely at the end of their life cycle. They might leave behind a small information diamond, like a clown car packed with infinite information clowns. But there is a third option. The information is safe, neither vanished nor hidden. Maybe our entire approach to this is wrong. We know black holes trap information, then likely delete it. But we never considered what else they might be doing simultaneously. Where do black holes store their own information? Cosmic storage? Let's create a black hole using dirty laundry. First, we fill the room with laundry baskets full of dirty clothes. The more dirty laundry you want to store, the more laundry baskets fill the room. At some point, every basket is full, and the room is completely filled. Not even a single sock can be squeezed in. The room is now at maximum capacity, but if we force a sock in using a lot of energy, it would cause the room to collapse into a black hole. However, the room's capacity itself hasn't changed. It is still impossible to fit more items or information inside. So what happens if we try to throw more dirty laundry in? The room itself would expand slightly, making space for the new information. Originally, every bit of information a black hole absorbs, its surface grows a little. In short, the more information, the larger the surface area. The information is displayed on the surface. It is like what happens when we toss a stone into a pond. Once the stone sinks to the bottom, we can no longer see it. Yet we know something fell in by the ripples on the pond's surface. Even the smallest black hole stores more information on its surface than all the data ever produced in human history. They achieve this by storing information onto an incredibly tiny pixel. A black hole is the ultimate hard drive. It is a bit like converting a paperback book into an e-book. These two things seem completely different. Yet their contents are identical, just encoded and stored in a different way. Black holes devour stars and planets, much like digitizing every book in a library. This is called the holographic principle. But if it is correct, everything we know about the universe is wrong. The universe is a holographic projection. If information is truly stored at the black hole's boundary, Hawking radiation could potentially remember and carry away the encoded information. So even if the black hole completely vanishes, the information wouldn't vanish, and our physics wouldn't need to be rewritten from scratch. The information paradox is solved, but we still need to fundamentally change how we understand reality. If everything that falls into a black hole is stored on its event horizon, this essentially means three-dimensional objects are encoded on a flat surface. We've given this a name, the holographic map. A hologram is like a 3D photograph, a flat plastic sheet encoding a three-dimensional image within it. A black hole is like a hologram, because everything inside it is encoded on the event horizon. To someone inside the black hole, it would feel like they're living in normal three-dimensional space. But to us on the outside, they're just flat pictures on the surface of the black hole. This result sounds counterintuitive. But hold on a moment. Black holes are extreme objects, yet they still follow the same rules as everything else. So if this crazy duality between 2D and 3D applies to black holes, it might just as well operate across the entire universe you inhabit. Since those inside wouldn't realize they're encoded on a flat surface, we might share the same fate. You could genuinely be stretched out on a platform at the edge of the universe. The science behind this theory is incredibly complex and quite bizarre. It uses miniverses for simulation, incorporating string theory and a whole lot of mass. We'll explore this further in another video. Whatever the true nature of the universe may be, we only know it is strange and complex, and we must delve deeper into physics to understand it. Yet black holes might hold the key to grasping reality's essence. This video was supported by the Swiss National Science Foundation and realized with scientific advice from Alessandro Sfondrini. Traditional Chinese translation, SCT Frühbrei, Vimesics.